Mean path length of alpha particles in air is given by this formula. R is 0.98 10 to the power minus 27 V naught cube. So basically, the mean path length is proportional to velocity cube, where V naught is the initial velocity of the alpha particle. Using this formula, find for an alpha particle with initial kinetic energy 7 mega electron volt its mean path length, the average number of ion pairs formed over the whole path, as well over its first half, assuming ion pair formation energy is 34 electron volt. So what is happening is these alpha particles, when they are released in air, they have a mean path length, which means they eventually come to stop. So why they come to stop, that hint is given to us in the last line, that ion pair formation energy is this. So what happens is we have an alpha particle with, let's say, initial velocity V naught, and in air we have a lot of particles. So let's say they are ionizable particles in air. So these particles, when they get hit by the alpha particle, they get the energy and they ionize. So obviously they take up some of the energy from the alpha particle, and that energy which they take up is given as 34 electron volt. So alpha particle starts to lose energy when it strikes some of these particles. So it loses energy every time one of the particles is ionized, and eventually it comes to rest. So this mean path length R is given to us, which is proportional to V naught cube. So let's read what we discussed. Every time alpha particle strikes one of the particles, ionizable particles in air, an ion pair is formed and alpha particle loses 34 electron volt of energy until it eventually stops. So now let's do the problem. So mean path length. So we need to find R if energy of the alpha particle is given. So energy is given, from there we can find V naught, and therefore we can find R. So R is this, we need to find V naught cube, and we know V naught is root of 2E by m. So E is the kinetic energy of the alpha particle, which is given to us. So that's what we'll do. So R is given as this into V naught cube. So this is twice into E, 7 mega electron volt by mass of alpha particle into 10 power 3 by 2. So why we did this 10 power 4? Because this formula is given to us in centimeter. So we need to put the V naught cube also in centimeter. So here when we have energy, so inside energy we will have a term of V square. So V square will be in meters. So when we convert that into centimeter, it will be 10 power 4. So that's what I have indicated here. So inside the bracket, we have the term of V square. So that V is in meter per second. So to convert it into centimeter per second, we need to multiply it by 10 power 4. So we do that and we get our answer 6.02 centimeters. Now second part, the average number of ions formed. So that will be simply divide. So this is the total energy, and every time one ion is formed, this much energy is gone. Total number of ions formed is E naught upon 34 electron volt. So E naught is 7 into 10 power 6 upon 34, which gives 2.06 into 10 power 5. So these many average ion pairs are formed. Now this is for the whole path. Now over the first half of the path, so this is quite interesting. Let's take it up on next page. So this is the whole mean path R, and half path will be R by 2 and R by 2. We need to find in the first half how many ions are formed. So from the diagram you might be thinking it will be just half of the total ions, but that is not the case. Now even I don't understand why it is not the case, but it is what it is. All right. So let's figure out how many particles are formed in the first half. So for the second half, we can see that if the velocity here is Vh, so let's say the half wave velocity is Vh, then again we can use this formula to figure out the value of Vh, because r will be replaced by r by 2. And if we know the new Vh, then we will know what will be the energy of the alpha particle here, if we know Vh. And if we know the energy of alpha particle here, then we know how much ions are formed in this half. So that will subtract from the total number of ions for the whole path, and that will give how many ions are formed here. So once again, I'll quickly explain the approach. So we know V naught, and we need to find how many ions are formed here. So if we, for the half path, so for the rest of the half path, because the alpha particle comes to rest here, so the same formula applies from here to here as well. So for r by 2, we can find what is Vh. And if we know what is Vh, we will know what is the energy of the alpha particle here. And if we know that energy, so that means that whole thing is coming to rest from here to here. So we will know how many ions are formed in this half. And we already saw in the previous B part that how many total number of ions are formed. So from that, if we subtract these number of ions, we'll get our answer. So let's do that now. So we see that from that formula, R is proportional to V cube. So R naught by V naught cube is equal to R by 2 by Vh whole cube. So this is also R naught actually. So from here we get Vh is equal to V naught upon 2 power 1 by 3. So if we square that, we get Vh square is equal to V naught square by 2 power 2 by 3. So why we are squaring? Because E is proportional to V square. So now we can write EH is equal to E naught upon 2 power 2 by 3. So now, and we are given what is E naught, right? That is this. So ions generated in first half is total ion pairs minus second half ion pairs. So total ion pairs are E naught by 36 minus EH by 36 in second half. So EH we found, so we'll put that here and we'll get this, and E naught is 7 mega electron volt. So that divided by 36. Actually, yeah, E naught by 36 we already found here. So E naught, why are written 34 here? Oh, it is 34 only. So there should also be 34. So yeah, E naught by 34. So these are the total particles formed. So this should also be 34. All right. So E naught by 34 we already saw in the B part. So that is the total number of ions formed, which is this. 1 minus this comes to be this, and this is our answer for the first half. All right. Actually, quite interestingly, you can see that this fraction is less than 1. So in the first half, less number of ions are generated, and in second half, more number of ions are generated, even though velocity here is more. So like I said, I don't know why, but this formula is given to us. So that's how it works. All right.